Lesson 66, Solving Inequalities by Adding or Subtracting. Recall that we can add or subtract the same number from both sides of an equation and it remains a true statement. So it says, for example 1, solve the inequality and graph the solution on a number line. We're going to solve this exactly the same way that we would if it were an equation. We're going to treat this inequality symbol just like it were an equal sign. So to get x by itself, I hope you see very quickly that we need to add 8 to both sides. Those will cancel, leaving me with x is greater than negative 4 plus 8 is 4. So on my number line, I'm going to show 4 here in the middle. We'll go 5 and 6, 3 and 2. You see that they keep going. The point that I'm talking about is 4. Remember that it's going to be open if there's not an equal sign, and there's not one, so it's going to be open. And I can see which direction to shade by making the inequality into an arrow, as long as my variable's on the left side. So I'm going to make it into an arrow, which means I'm pointing to the right. That's my final answer for example 1. Solve the inequality x minus 2 is less than or equal to 3. I want you to do that on your own paper, so please pause the video at this time and work out the solution and graph it. So you should have started by rewriting the inequality x minus 2 is less than or equal to 3. To get x by itself, we're going to add 2 to both sides. So I have that x is less than or equal to 5. So now I just need to graph it, and I'm going to show 5 as being in the center. Whenever you do these on your own paper, I only need you to show me 3 or 4 points. I don't need a whole long list. And make sure that whatever you're talking about is in the middle so that you're not making a huge long line for, to graph something. It should be very quick and simple. So this one has the equal to sign, which means I'm going to shade it in. And my variable's on the left, so I can change my sign into an arrow. It says point to the left, which is this direction. Okay, so this means 5 and numbers less than 5, this should be true for. So I'm going to choose a random number less than 5, which is going to be 2. That's the number I'm going to choose to check with. If I plug in 2 for x, 2 minus 2 has to be less than or equal to 3 for it to be true. 2 minus 2 is 0. Is 0 less than 3? Yes, it is, so it checks. Alright, same thing here. I want you to try this one on your own paper, so go ahead and pause and graph whenever you're finished. You should have started by rewriting the problem. X plus 5 is less than 7. To get x by itself, we're going to subtract 5 from both sides. 5's will cancel, leaving me with x is less than 2. So the point that I'm going to show is 2. And I'm going to say 3's over here, 1's over here. My point is at 2, so I'm going to draw my circle there. It doesn't have the equal to, so I'm going to leave it open. If I make my sign into an arrow, it's pointing to the left. So I would shade this way. Okay. To check it, I need to choose a number less than 2, so I'm going to choose negative 1. If I plug in negative 1, negative 1 plus 5 has to be less than 7. Negative 1 plus 5 gives me 4. 4 is less than 7. It checks. Last example says Michael's horse can carry no more than 200 pounds on its back. If Michael weighs 168 pounds, how much can his saddle weigh? Okay, so the horse cannot carry any more than 200 pounds. Okay, 200 pounds is the most. So I know that whatever it is has to be, whatever is on the horse, okay, has to be less than or equal to 200 pounds. And I know that Michael weighs 168 pounds plus the weight of his saddle, which we don't know, so I'm going to put X. On your own paper, I would like for you to solve this and have that in your notes. That's all I have for you tonight, so I hope that you've taken good notes, and I will see you in class tomorrow.